left off. Now, I'm going to do this two ways. Eventually, you'll get to where you don't need to see a graph to do this. But piecewise are always a little new to us, and so just for fun, before I ever start, I am going to sketch a quick graph and see what this thing looks like. Which will probably answer all the questions, but then I'll do the calculus behind it, and you can kind of see the connections between the two. So if I were to graph it, left of 0, I have a parabola up 4 units reflected over the x-axis. Filled in dot. And then to the right, I have the graph negative 2x. What's the y-intercept of that? 0. So I'm going to open circle at 0. The slope is negative 2 down to the right one. This is the graph that I am working with. So I'm going to show you how the calculus relates. We would find the first derivative. It does have two pieces, doesn't it? What is the derivative of the top piece? Negative 2x. I am going to make a little change here. I'm going to say only when x is less than 0. Why would I do that? What is the derivative at 0? Undefined. Why? Because there's two pieces, it's not continuous. Even if it were continuous, it's probably a sharp corner. Most piecewise functions aren't differentiable at the breakpoint. Now I will show you how to test whether it is or isn't. Most of them aren't. It has to be a very special case for it to be differentiable at the breakpoint. Negative 2 is the derivative of the bottom. X is greater than 0. Now I want to look to see when these equal 0 and when they are undefined. An immediate place that might be undefined on a piecewise is the breakpoint, right? So 0. And to know for sure if it's undefined, I'm going to look at the derivative of the top at 0. What is this at 0? 0. What is this at 0? Negative 2. Are those the same? So at 0, the derivative is undefined. So I have a critical point. A critical value at x equals 0. And then I'm going to look to see if either piece is 0 or undefined on its own. Negative 2 is not equal to 0 and it's not undefined. Negative 2x is equal to 0, but at 0 I already kind of flagged that as a critical point anyway, so sounds good. Make sure that if this does equal 0, you only consider points that are less than 0. So if it equals 0 at 5, who cares? Because we didn't draw that curve at 5. Does that make sense? So only think about it in that piece. I'm going to do a sign chart. Where will I plug in numbers that are less than 0? Into the top, less than 0. In the derivative on the top. So negative 1 times negative 2 is a positive. And then the ones in the bottom, they will always be negative, won't they? Any questions about that so far? At first glance, we would consider this a relative maximum, right? And actually, this particular problem, they will give it to you either way, but be careful. If this happened to be above that point, then it couldn't be a relative maximum. So it does depend on where that other piece of the curve starts out. It is a relative maximum, but we did need to be careful about the two pieces of that graph and how they relate. So piecewise are always a little tricky. It's increasing from negative infinity to 0, decreasing from 0 to infinity. And you can call that a relative maximum at 0, 4. So just wanted to show you kind of what a piecewise function looks like and tell you you probably will always need to think about the graph when you do a piecewise, if it's possible for you to graph it, if you're doing a first derivative. Now increasing and decreasing, did we need to know what the graph looked like to figure that out? That was pretty easy. But as far as relative extrema, be careful and think about the graph. Okay, now we're going to talk about absolute extrema. I hinted around it just a little bit yesterday, but absolute extrema is a little different than relative extrema because I want to know the absolute maximum value on the graph. I want to know the biggest value or the smallest value on the graph. Where did we find out yesterday that those could happen at? When the derivatives 0 are undefined, so critical values, or at endpoints. So we have something else to think about, and that's endpoints as a possibility. So this defines x squared on -2, 5. I picked one that you could visualize first. This is a parabola defined only from x being -2 to x being 5. You probably already know where the absolute max and absolute min are. 0, 0, and 5, 25, right? Just by your knowledge of graphing. So let's see how we figure that out. Step 1, you need to find the critical points. So as always, we need to identify the critical values. So x equals 0 is our only critical point. Now you have two options from here. You can go ahead and decide if that's a relative minimum or not, or you can go straight into what we're going to call a candidate's test. This is a very elementary feeling test. Definitely doesn't feel like calculus. We're going to figure out which one is the absolute max and absolute min by plugging them all in and seeing which one's the biggest and seeing which one's the smallest. And that's how we're going to tell them. It's called a candidate's test. So it's a test for absolute extrema. Find the critical points and the endpoints and do a candidate's test. So I'm going to do f of 0. I'm going to do f of the endpoints. Okay, so I'm going to do f of 0, f of -2, and f of 5. If you are only looking for a relative or for an absolute minimum, then it might be a good idea to identify whether this is a min or max, just to limit how many things you guys guess. But just that's up to you, whether you figure that out or just go straight to the candidate's test. Probably depends on how hard it is to plug this stuff in. Which way you want to do that. This one, it's so easy to plug it in, we might as well just plug them all in, right? F of 0 is 0, f of -2 is 4, f of 5 is 25. Which one is the biggest number? 25, right? Why that, right? 25 is the biggest. What's the smallest? 0. So our absolute minimum value is 0 at x equals 0, and our absolute maximum value is 25 at x equals 5. So to find absolute extrema, you still have to find your relative extrema, but then you have to check your endpoints and see which one's the biggest value and see which one's the smallest value. So we find the possibilities, the candidates, and then plug them in to check and see which one's the biggest and which one's the smallest. Any questions about that one? So I picked an easy one first, one that you can visualize, and then I picked this other one that you probably don't know the answers to, just by looking at all this stuff. Depending on how good your logarithmic graphing skills are. What's the first thing I have to do? Take the derivative. What do I get? Are there any critical values? -1. Why do I not care about -1? The bottom. 700. It's not in my interval. I'm looking for a maximum on 0 to 3, right? -1 is not between 0 and 3. So I don't care about that one. Yes.
So do you ever set the top equal to 0 or it's always the bottom?
equals 0?
It doesn't.
It doesn't. So always both, because you want critical values. You want any place the derivative is 0, any place the derivative is undefined. This doesn't matter. So what are my only two candidates? 0 and 3. That means that this function, if we were to do a sign chart from 0 to 3, is either always increasing or always decreasing. Which makes sense on a logarithm, right? Isn't the logarithm always increasing? So the left-hand most point is probably going to be the absolute min, the right-hand most point is probably going to be the absolute max because it's an increasing function. So this does make sense. -1 was a critical value because natural log is actually undefined at -1. -1 plus 1 is 0. And what is natural log of 0? Undefined. So my only two candidates are 0 and 3. So I get natural log of 1. What is natural log of 1? That is something you need to know. It is 0. You don't need to know natural log of 3, but you do need to know that it's bigger than 0. So this is my absolute maximum. This is my absolute minimum. How do we feel about candidates tests?
The second one would be element 4.
Oh, you're right. Thank you very much. Still don't know what natural log 4 is, so we'll just leave it as natural log 4. Thank you. Any questions about that one? Okay, this is just something to kind of get us thinking. That what we just did sums up most of your homework. So pretty much done. We just have a few little things we want to look at. And one of those is sketching the graph of the derivative of f given the graph of the function, and maybe vice versa as well. So this is the function f, and I want to know what the graph of f prime looks like. Anything you know about it? Okay, decreasing and then increasing. Does everyone agree? So the derivative would be negative and then it would be positive. When does it change? At 1. So would you agree the derivative 0 at 1? And then here it's a positive slope, but it's small, but then it gets bigger and bigger and bigger. Something like that. And then the other way is negative, they start small and they get bigger as we go out. Does it make sense that you would have a line that's a derivative of that parabola? So that's the graph of the derivative. Okay, this is an interesting question. This says use the graph of f prime. So this is the graph of f prime. So it's this one down here. Use the graph of f prime to identify intervals where f is increasing and decreasing, and estimate the values where f has a relative maximum or minimum. In a couple months, you will do this without drawing a sign chart or anything. You'll just look at it and go, oh, I know the answer. But for now, this is new to us, so it's pretty tricky. So I'm going to draw a sign chart. Anytime I want to do those things, that's what I want to do, right? My sign chart is for the function f prime, right? That is the function f prime. Where is f prime 0? 2 and 8. How do you know? Where it crosses the x-axis. Before 2, is it positive or negative? Negative because it's down here. Everyone agree? And then it's. Has anyone lost about how I'm getting this from the graph? Okay. And then negative. Now with the picture, it's an easy answer, right?
Do we need to put like when it's like the horizontal?
Do we? Wouldn't that be the second derivative being 0? Because this is the derivative, remember?
So we don't have to put like 5.
Because that's not a critical point on the original function. That would be a second derivative critical point. Maybe we need that someday. for now, this is the only thing we need. So when is my function increasing?
2.
And when is it decreasing? And now notice, does it ask you to find the maximum and minimum values? It only asks you to find the x, y. Can you find y? No, I don't have f of x, so I can't find y. That's why it said only find x values. So I have a relative max. Where at? Good. And it might help you to draw this part. And what about a relative min? Again, if you can do that without drawing a sign chart, you are welcome to, but for a while it'll probably be nice to draw that sign chart to connect that back to f of x. So you try the bottom ones. So remember, this is the graph of the derivative. Find intervals of increasing, intervals of decreasing, and relative extreme. How many of you like drawing a sign chart on this? At first, you'll get to where you don't need to. First, it's very useful. Okay, what goes on the sign chart? Okay. Any questions about that? That's where f prime is equal to 0. And then what's the value before negative 3? After negative 3? Decreasing, increasing, decreasing, increasing. So we are decreasing negative 3, negative 1, 2, increasing from negative 3 to negative 1, 2 to infinity. Relative maximum at x equals negative 1, and relative min at x equals negative 3 and 2.
But you say that relative and the absolute both the same.
Now, relative are any peaks and valleys. Absolute is the highest peak or the highest valley. On this particular function, if you were to go back to the original, it's a 4th degree polynomial. It does have an absolute minimum, but it does not have an absolute maximum. But do I know which one of these is absolute without having a function? I'd have to have a function, so I would plug them all in to see which one was the lowest, and I don't have that. So without an original function, you have no way of